All right, let's do what we love best, guys. I was supposed to. I know this got cut in the last video where we had said that cos 16x will be then 2 cos squared 8x minus 1. You just half of that. Just get half of that and then you do it. Okay? So now let's do the trick, the questions, the identities. Let's do number 3A as fast as we can. Shouldn't take us any time. So they said we should show that sine 3x over sine x cos x is going to be equal to 4 cos x sec x. Okay? Let's go ahead and let's do it. So what are we going to do here? What you do is for this, first thing you do is, now I'll actually at the end of the video show you that they made a mistake here. It was supposed to be 4 cos x then minus sec x. Okay, I double, triple, whatever, quadruple checked it, even with multiple softwares as well, to just make sure there was a minus there, which was not put by the computer, but it's still fine. This is 4 cos x minus sec x. Okay, so now let's do it. What is this going to be? Well, now here's the thing: what you do when you get something like a sine 3x or whatever, you must be able to change it to what it actually means, because you have to do something here. We are going to have to do something here to be able to go get to this stage. Now, things that give me tips is like to see a sec x. I know that I'm going to have to change something. I'm going to have a sine x at the top somewhere here. So how am I going to do it? I work with this sine 3x. What is sine 3x? I can change it to be two parts. I can make sine 3x be sine of 2x plus x. Okay? And it'll be over sine x cos x. So I've changed 3x to be 2x plus x. It's still 3x, okay? But I've separated it. Because once I do this, then I can do the expansion. We've talked about it. How do you do the expansion? For sine, we said it comes together with cos, but sine goes first. So it'll be sine 2x, then cos x. Then now we start with the cos. So it'll be now cos 2x, then sine x. Okay, that's how it does it. They go together, but sine starts first and cos gets the other one. Then cos starts first and sine gets the other one. And if this is a plus, then it'll be a plus again here. You remember we did it when we were doing for sine of a plus b. You remember that. I know you do. Come on. We said it as sine a cos b plus, because there's a plus here. Then we said you now say cos a sine b. That is what we have just done. Okay, either way, now let's continue. This now becomes, we can put it all over sine x cos x. Okay, we can put it to be like this. Now, what should we then do here? Because I see I have a cos 2x, I have a sine 2x. So what should I do? Well, I know what to do. I know what to do. I'm going to work on these guys that are double angles, because I don't have them in the final identity here. I have 4 cos of x, then sec of x, so there's no 2x. So I should eliminate these, and I know my double angle formulas. What is sine 2x? Remember, sine 2x, we said it is 2 sine of half of 2x is x. So 2 sine x cos x. So this is going to be 2 sine x cos x, okay, instead of this sine 2x here. And it's going to be times this cos x, okay, times cos x. Then plus, now here, cos 2x, what are we going to put? For cos 2x, we can put anything we can put from, since I have a cos and a cos, I know these two coses will become cos squared. So for cos 2x, I also go to the one here, cos squared, which is going to be 2 cos squared x minus 1. And this is multiplying sine x. So now what will I end up having? Well, this is still all over, please. I forgot. It's still all over sine x cos x. Okay, I saw that this is going to be a cos squared, so I decided to make it like that here as well. This now becomes 2 sine x, then cos x times cos x, these two. We'll just multiply these two and they'll become cos squared x. Then plus, here we have 2 cos squared x times sine x. It becomes 2 sine x cos squared x. Then sine x times negative 1, because this sine x is multiplying this whole bracket. So it multiplies this, then it now multiplies negative 1. By negative 1, it just becomes negative sine x. And it is all over sine x cos x. Now, what is this 2 sine x cos squared x plus 2 sine x cos squared plus 2 sine x cos squared? It becomes 4 sine x cos squared x minus sine x all over sine x cos x. Then now we are allowed to split the numerators. Remember that. Always remember that. Numerators you can split. What you don't split is the denominator. So in here we can say this now just becomes equal to 4 sine x cos squared x all over sine x cos x. Then minus, because you are splitting the numerator, it's minus sine x all over, still the same thing, sine x cos x. So what am I going to end up having now? Well, with the pencil, you cancel softly. You show that sine x and sine x will cancel. Cos x into cos x1 into cos squared x will remain with a cos x, okay? Because cos squared x had like 2 of them, now 1 is going. So now it becomes 4 cos x here, minus here we say sine x and sine x will cancel. Then you remain with 1 over cos x. And this now just becomes 4 cos x minus 1 over cos x is what? Is sec x. You remember them, right? Because 1 over sine x, this is cosec x. I know in cosec they write it as a CSC, cosec x. And then 1, I know you'll be saying, isn't cosec 1 over cos? No, cosec is 1 over sine. Then 1 over cos x is now sec x. Although they sound like they wouldn't agree, but it's true. Then 1 over tan x is cot x. These are the things. You see, how good is this? Anyway, we will end up having 4 cos x minus sec x, which is what we said should be the solution in this one. And you'd be done with your part A, okay? Now we'll go to part B in the next video. Goodbye for now.